Okay, so we are in section 4.5, where we're working on first order ordinary differential equations. And they are solvable if they are in the form dy dx plus p of x, y of x is equal to q of x. So this is where we were. We had finished the derivation, so we got the solution in terms of an integration factor, which we called V. Some people call it nu. And then we went on to solve two problems. And so we were complete with that. So we are now at solving problem number 3. All righty. So I will remind you of the steps, our technique. And I'd like to know who wants to start walking me through this problem. Hello. I see I have, wow, I have 14 people on here already. Okay, let's start with this. Is it in standard form? Let's start there.
No.
No. Okay, so Devin, what do I need to do to get it to be in standard form?
I kind of forget, but do the same variables need to be on the same side?
Okay, so that's if we're looking at the separable type. This one, it has to be in the form that we said. So we want it to be in the form dy dx plus p of x y is equal to q of x. And the problem is here in this problem, number 3, I have an x in front of the y prime. So it has to go. So we're going to divide everything through by that x. And I get y prime, that's my dy dx, minus 1 over x y is equal to 2. And then when I divide that by x, I just get 2 times the natural log of x. So I divide every term by x. Okay, now it is in standard form. So now that it's in standard form, the first step is to identify P of X and Q of X. Okay. So our first step is to identify P and Q. Okay, so somebody want to do that for me?
Is P of X the 1 over X?
It is, but it's negative, so we need to include that. Okay, keep going.
And
Q
then
of X. Oh, my bad.
Go ahead, Devin.
this is just 2 ln X.
That's right. Okay, who was that jumping in there? Was that Ezekiel?
Yes, that was me. Sorry about that.
That's all right. You're going to do part 2. So part 2 says find the integral of P of X dx. So let's work on that, Ezekiel. And let's first, anybody else that wants to chime in? This is the integral of negative 1 over x dx. And what is that integral?
Negative natural log of The absolute value of X.
Awesome. Okay, so now we have this piece of information here that X is positive. So since X is positive, I don't need the absolute value. And then I'm going to use a log property to simplify this to make it the log of X to the -1. Why would I want to do that? Why would I even bother to do that?
Is it going to be easier when we have to take the E value, like E
That's
to the natural log?
That's absolutely correct. Okay, so now when I go to find V of X, which is E to the integral of what I just found, that is E to the natural log of X to the -1, and that is X to the -1, or just 1 over X. Okay, so that makes my life easier. Okay, step 4 is to compute the integral of Q of X times V of X dx. So that is the integral of 2 times the natural log of X, and that multiplies by 1 over X, that's the V dx. Now I need to integrate that. Is there an easy way to compute this integral? In other words, do you see a function with its derivative sitting nearby?
Can we let natural log of X equal U?
Okay. And then du is equal to
Wouldn't it be 1 over X
1 over X
dx?
dx. Good. Now this is nice because as you can see, the whole 1 over X dx, that takes up this whole piece of the problem. And then this piece, that takes up this part of the problem. So we have a complete substitution. This is 2 times the integral, the log of X, I'm going to put in U, and 1 over X dx, I'm going to put in du. So this becomes 2, it integrates quickly to U squared over 2. And here is where I do need to keep the constant. So at this part of the stage, we have no constant. So back here, when we integrate, there's no constant.
Hold on, could you re-explain how you got the 2 times U squared over divided by 2?
I can. All right, so do you recall this step here? Right, you see where I am?
Yes.
Okay, so in that step, we had the 2 times the natural log of X, that part was Q. The 1 over X dx was U. So we substituted and we got U was the log of X and du was 1 over X dx. So we got a complete substitution. And then when you integrate X to the N dx, remember we get X to the N plus 1 over N plus 1 plus a constant. So the only thing I did different was I integrated u.
Okay, that makes sense now.
Okay, so I integrated u. All right, so this just comes out to be u squared plus a constant. So that is the natural log of x, the quantity squared plus c. And then the last step, which is 5, is that y of x is equal to the quotient of what we just found, the integral of q of x, v of x dx, plus the adjoining constant over v of x. So we end up with the log of x, the quantity squared plus a constant, and that whole thing gets divided by v, which is 1 over x. So therefore we get y of x is equal to x times the quantity, the natural log of x squared plus c. And we are done. I don't have an initial condition, so I don't have to solve for a constant. I cannot solve for a constant. So that is my answer. Any questions? Okay. Let's look at problem number 4. Okay, so tell me something about this problem. I don't care what it is, just tell me something about this problem.
Tell you something.
Yep.
Is it in standard form or no?
Yeah.
Well, that's what you need to tell me.
So the X would be your P.
So X would be P. I think it is in standard form already. So X is P is X, and what is Q?
X.
It's also X. Okay, so that's the first step, finding P and Q. All right, next part.
Get
What
the
do I have to
derivative.
do?
Get the antiderivative. The derivative.
An antiderivative of P of X. Very good.
That's 1/2 X squared.
1/2 X
Squared.
squared. Okay, remember at this stage, no constant. Okay. Next stage, what do I do?
What plus C?
Okay, remember at this stage, we don't need a constant.
Oh, no constant. As you plug in a -6, y 0 equals -6.
Oh, we're not there yet. We don't plug in y of 0 equals -6 until we have y of x equals. When we get there, then we'll plug in y of 0, but we're not there yet.
We need to compute v of x.
We need to compute v of x, okay? So we finished steps 1 and 2. We now need to compute v. So v of x is e to the integral of what we just found. So that's e to the 1/2 x squared. So that is v of x. Okay, What's step number 4?
Now, yx equals,
Nope, we're not there yet.
oh,
Is this going to be the integral of q of x times v of x dx?
Okay, so we need to compute the integral of v of x dx. So that is the integral. Q of x is just x, and v of x is e to the 1/2 x squared dx. All right, how do I compute this integral?
how do you compute it?
Yes. How do I compute this integral?
A substitution.
Correct.
All right, substitution.
So I think u could equal 1/2 x squared at
Yeah.
first.
Okay, so let u equal 1/2 x squared. All right, Danielson, then what does u equal?
du would be equivalent to just x. Yes, x dx.
X dx. Okay, so
So
how
then you
nice is
can,
that? Yeah, go ahead and do your substitution. What is it?
yeah. So then you can substitute the x dx in the actual problem for just du. The integral of e to the u du,
Perfect. And what is that?
and that is just e to the u.
And here is where we need a constant, okay? So this becomes e to the 1/2 x squared plus a constant. Thank you, thank you. All right, now, step number 5. Y of x. Johnny, you should be getting excited because we got y of x equals. We're almost there. It's the quotient of what we found, e to the 1/2 x squared plus a constant divided by v, which is e to the 1/2 x squared. So this just gives me 1 plus c times e to the negative 1/2 x squared. Okay, so now I'm going to put a box around here, but this is going to be my temporary box because I'm not done. Okay, oh, my box is too small. Let's make my box a wee bit bigger. Thank you. There we go. Okay, Johnny, we're here. I have y of x is 1 plus c e to the negative 1/2 x squared. And now I must use the fact that y of 0 is equal to, and I believe I said -6. -6. Okay, so what do I do?
Plug in -6 would be x, and then 0 would be 0 equals 1 plus CE.
Okay, which one is x and which one is y?
Y is 0. Wait, y is -6.
Good, okay. So you get -6 is equal to 1 plus c e to the 0. E to the 0 is 1. C is equal to -7. Okay, so now we get y of x is equal to 1 minus 7e to the negative 1/2 x squared. And we are done. Okay, so you can't take and utilize your initial condition until you've gotten to the point where you know what y of x is, with the exception of the constants. Okay, any questions about that? Okay, I am going to stop for a minute. Oh, no, let me see, where am I? I feel like I have, that was number 4. I do have another problem. Okay. But before we do that, okay, I gotta find my screen again. There we go. Uh-oh, there we are. Here we are. Okay, so let me go back. Now let me find my screen. Where are you guys? Oh, there you are. Oh, okay. All righty, let's get ready to play Kahoot. Okay, I'm going to get it started. It's loading the game pen. Can everybody see it? Okay. All right, 744-8193. You can scan.
Dr. Lar,
Yes,
sorry I have to leave early for class to make up a test I missed last week.
I saw that. Yes, sir.
Okay, just making sure. Thank you.
All right, you're welcome. Hi, Benaya. Thank you. Thank you for joining. Hi, Jose. And Ayana, Devin, Ezekiel, Brian, Johnny, Danielson, Aaron, Bianca, Joshua. Okay, I have 11. Let's see who else. Oh, it's 19 people on this call. I'm waiting for a lot. Okay, Rodney, thank you for participating. Nathaniel, thank you. Annalise, thank you. Ezekiel, thank you. I think I have 2 more. I'll give you another few seconds to log in. If you get kicked out, the game pin will be in the corner. Okay, now short answer questions where you have a choice of 4, they will be, you will get 20 full seconds. True, false, you only get 10 seconds. And the last question, you will get a full 2 minutes. Okay, so I'm still missing 2 people, but I'm going to go ahead and get started in a second. I'm not sure who I'm missing, but I'm missing 2 people. Uh-oh, I lost somebody. Okay. All righty. Euler's method is used to solve separable differential equations, first order differential equations, both or neither. Okay, very good. Majority said both. We say an improper integral diverges when the limit goes to 0, the limit goes to positive or negative infinity, the limit is equal to L, or none of the above. Okay, good. The majorities got it correct. We're doing better than we did the last time we played. Okay. A first order differential equation in standard form is, okay, please look at your choices. Red, blue, I guess that's mustard, yellow, orange, and green. Okay, so figure out which one is in standard form. Oh, wow, okay. You guys are getting stronger. I'm really pleased. Okay. Which of these numbers does not appear in Simpson's rule?
Damn.
Okay. Didn't do so well on that one. Okay, we need to talk about that a little bit. True or false? The estimated error for the trapezoidal rule is smaller than the estimated error for the midpoint rule. Okay, true or false, or 10 seconds, so they go quickly. That was split. Okay. The midpoint rule is used to estimate the volume of revolution of a curve f of x, the area under a curve of f of x, the surface area of revolution of a curve f of x, or all of the above. Now that's pretty awesome. Okay. The comparison theorem is used to determine when an improper integral is convergent. True or false? Okay. True or false? An ordinary differential equation contains an independent variable x, a dependent variable y, and derivatives of x and y. Okay, it does not contain derivatives of x. In a first order differential equation, y of x is equal to okay, that constant is actually in the quotient. Okay, it is inside the quotient. The solution to the differential equation provided dy dx is equal to x over y, y of 0 is 1, is a hyperbola, is undefined, it's a circle of radius 1, or none of the above. So you have a full 2 minutes to solve that differential equation. Okay, you're down to 10 seconds. I only have 12 answers. Okay, it's a hyperbola. Okay, let's see where we are. 6 out of 10. All right, Ezekiel Chien. 5 out of 10. Jose, 6 out of 10. Bianca, fantastic. Runners up are Nate and Benaya. All righty.
Sorry, Dr. Locke. There were some questions that I actually got wrong. I picked by
Oh.
accident. I'm sorry.
It's okay. So my question to you is, are there any questions about any of those that we did before we go back to this?
Is it possible if we could scroll up to question number 3? I forgot to record the last answer for after step 5. Step
Question-
5 on question 3.
Here?
Oh, okay. Oh, so the natural log of x cancel out with the 1 over x because there are 2 of them?
Say
Or
that
no?
again.
How did we get the last answer?
Oh, because when you divide by 1 over x, that's the same as multiplying by x.
Oh, so the x cancels out and then,
Okay, the x does not cancel. Here's the x. When you divide by a fraction,
you multiply by reciprocal or no?
multiply by its reciprocal.
Oh yeah, I see now. Yep, thank you.
Okay, awesome. Okay, any other questions? Okay. All right, so let's do an application of a mixture problem. Okay, so here's an application where we actually do use the first order differential equation. And this happens to be a mixture problem. Okay. So we have a tank. It contains 100 gallons of 10% concentrated salt solution. A solution containing 1 pound per gallon of sodium chloride runs into the tank at a rate of 1 gallon per minute. and the well-stirred mixture is pumped out of the tank at a rate of 1 gallon per minute. How long will it take before the mixture is at a concentration of 75%? Okay, so we are going to use the principle that the rate of change of the amount of a substance in a container is going to be equal to the rate in times the concentration in minus the rate out times the concentration out. Any questions? Okay, so let's start with the first thing, the rate of change of the amount of a substance in a container. So let's let Y equal to the amount of salt in the tank. Okay. So dy dt, oh, so the amount of salt in the tank, and this is in pounds. All right, so dy dt that is going to be the rate of change again in the amount of salt with respect to time. And for us, time is in minutes. So that is dy dt. And we know that dy dt, well, the change in Y is the change in pounds. And the change in time is the change in minutes. So therefore, dy dt is in pounds per minute. All right, so it'll change by X many pounds of salt in 1 minute. Okay, so let's look at the rate in. So the rate in, they told you is 1 pound, nope, is 1 gallon per minute. And the concentration in is equal to 1 pound per gallon. Okay. So if you take the rate in times the concentration in, you end up with 1 gallon per minute times 1 pound per gallon. And if we divide out units of gallons, we end up with 1 pound per minute. And notice this is the exact same units as my dy dt. Okay. All right, let's look at our rate out. So our rate out is also, this is our rate out. It was also 1 gallon per minute. And these problems can become much more challenging when the rate out is not equal to the rate in. So we're going to just work with this for right now. And our concentration out, well, the concentration out depends on the amount of salt that's currently in the tank divided by the volume of fluid. Now, since it's coming in at 1 gallon per minute and going out at 1 gallon per minute, then the amount of fluid in the tank never changes. So therefore, the amount of fluid in the tank is still always going to be 100 gallons. But the amount of salt in the tank, well, that's what we're trying to get an equation for. That's Y. So Y is the amount of salt in the tank, and that's Y pounds per gallon. So therefore, the rate out times the concentration out is 1 gallon per minute times Y pounds per 100 gallons. So once again, I'm going to divide out gallons. And this time I'm going to get 1 over 100 times Y pounds per minute. So once again, I have the same units. So since they're all the same units, I can make an equation out of them. So I have dy dt is equal to the concentration in the rate in times the concentration in minus the rate out times the concentration out. So I get dy dt RICI was 1 gallon per minute. And then I'm subtracting off our rate out, concentration out, and that was 1 over 100 times Y. So now if I just do a little maneuvering, I get dy dt plus 1 over 100 Y is equal to 1. So that is my differential equation. So this is the equation that's going to tell me how much salt is in the tank at any time t. All right. Now they did give me some information about the initial amount of salt. Let's go back and look at it. It says the tank contains 100 gallons of 10% concentrated salt solution. So at t equals 0, we have 100 gallons of 10% concentrate solution. All right, so if it is 10%, that means I will have 100 still. So at t equals 0, we have 100 gallons of fluid. So I need 100 gallons of fluid here. And that has to be 10%, which means I must have 10 pounds of salt to start with. So therefore, at t equals 0, the amount of salt in the tank is 10 pounds. So therefore, I now have the second part of the problem. Okay, any questions on the problem development? I can go back over a part if you need to. All right, so we started with this formula. The rate of change of the amount of a substance in the container is the rate in times the concentration in minus the rate out times the concentration out. Okay, so we used to find a rate in, concentration in, multiplied them, got 1. Rate out, concentration out, multiplied them, and got 1/100 times y. So therefore, I have a differential equation and an initial condition. Okay, so let's solve it. So we have dy dt plus 1/100 y is equal to 1. So step 1, what is P of t and Q of t?
P of t is 1/100 and Q of t is 1.
Okay, awesome. Okay. All right. Find, what do you need to find in step 2? I want you to complete that.
The antiderivative.
Okay, so we need the antiderivative of P of t. So that's 1, oh. The integral of 1/100 dt. Can't get any easier than that. That's 1/100 t. And remember, no constant. Okay, step 3. V of t. What is V of t? Okay, I know this is scary because it's so easy.
Is it the e to the integral of P of t dt?
Yes. So it's just e to the 1/100 t. No log, nothing difficult right now. That's it. That's it.
Oh, thank you.
Okay. The integral of Q of t with V of t dt. Integral Q of t is just 1. Okay, that's easy. E to the 1/100 t dt. How do you integrate that?
So we know e to goodness, can't stop. E to the 1/100 t is just e to the 1/100, right?
Okay, so I'm going to get
Plus c.
to the 1/100 t plus c, but remember the integral of e to the k t dt is 1/k e to the kt plus a constant. So when I divide by 1/100, that gives me a 100 out front. So now I get y of t says take what you got in the last step, which is 100 e to the 1 over 100 t plus a constant and divide by e to the 1 over 100 t. So we get y of t turns out to be 100 plus a constant times e to the negative 1 over 100 t. Okay, so that is the base solution. All right, so that is the solution without solving for the constant c. All right, so now we have to use the fact that y of 0 is 10. So we get 10 is equal to y at 0, but this is 100 plus c e to the 0, or 10 is equal to 100 plus c, or c is negative 90. So now I get y of t is equal to 10 minus 90 e to the negative 1 over 100 t. And that tells me how much salt is in the tank at any time t. Okay, am I done?
Yeah. No. Wait, no.
I hear yes and no. Did I answer the question?
Can we scroll back up to the question?
I certainly can. There it is. How long will it take before the mixture is at a concentration of 75%? Okay. So we need to find T when the mixture is 90%. Nope, I think I said 75. So just like we did before, we said when it was 10%, it was 10 pounds of salt and 100 gallons of fluid. So now I need 75%. So that's going to be 75 pounds of salt in 100 gallons of mixture. So that means I need y of t to be 75. So I need to solve for t. Okay. So I need 75 to equal y at t, but that has to equal 100 minus 90 e to the negative 1 over 100 t. So if I subtract 100 from both sides, I get negative 25 is negative 90 e to the negative 1 over 100 t. So let's divide by -90 and we will get 25 over 90 is equal to e to the -1 over 100t. So what can I do to get t out of the exponent?
Take the natural log of both sides.
Take the natural log of both sides. So I get the natural log of 25 over 90 is equal to -1 over 100 t. So that tells me t is -100 times the natural log of 25 over 90. Okay, so that says then t is equal to negative natural log of 25 over 90 up, and it's times 100. Okay, so I got 128.09. What are the units for this?
Is it gallons per minute?
What
I'd
is,
have to
what does T represent?
time
Mm-hmm. And in this
minutes.
problem, time was in minutes. Yeah, time was in minutes. So that's the number of minutes it will take. And if you're not too keen on that, we can take this number and divide it by 60. And that's a little over 2 hours. Okay, any questions? Now, as I said, if by chance you are pouring water in faster than it's going out, you will see that your tank is going to eventually fill and then overflow. And if it is flowing out faster than it's coming in, your tank will run empty. So those two problems are a little bit more challenging. I want to make sure you understand just what happens when the rate in is the rate out. Okay. So if I ran this for a little over 2 hours doing that, eventually the salt starts to build up in the system. And eventually it would be at 75% salt solution. Okay. This is an easy example. I just want you guys to go through it. Okay. How do we do number 5?
Just separate X and Y.
Okay, are you going to be able to separate X?
Oh wait, no, not yet. No.
So therefore, let's try putting it in standard form maybe.
Yeah, standard form first and then doing that.
Okay, so standard form, you get dy dx. So you get x dy dx plus 2y is equal to the cosine of x over x. Okay, so then we divide by x and we get dy dx plus 2 over xy is equal to the cosine of x over x squared. Okay, now it's in standard form. So what can you give me?
P of X and Q of X,
All right, so what's p of x?
2 over X, and then
Okay,
Q of X is cosine X divided by X squared.
good. So
And
right
then-
now it seems kind of hopeless. Okay, but we can figure this out. It's not too bad. Okay. So what do we need to do now? That was one. Step two,
Find the antiderivative.
p of x. So that's the integral of 2 over x dx. I feel like we did this one today already. All right, so that is the integral. Let's take the 2 out. The integral of 1 over x dx. So what does that become?
The natural log of the absolute.
Natural log of X.
Good. And I don't need absolute values because
Is positive.
x is greater than 0. Yes. And so we already know we want to try to isolate this so it's a natural log of x squared. Okay, so step 3, we get v of x is e to the log of x squared. So that turns out to be x squared. Step 4, the integral of q of x times v of x dx. And what does that become?
Well,
Q of x is cosine x over x squared. V of x is x squared dx. So this is just the integral of the cosine of x dx. What's the antiderivative of cosine x?
negative sign.
Okay,
X.
it actually is
Oh,
just,
positive.
and you can't forget your c, so y of x is equal to the sine of x plus c divided by x squared. And you're done. That's it. Okay, any questions?
Can you scroll back up to that second step?
There,
Yeah, right there.
okay.
I got it.
Okay. All righty, I am going to end here. I don't want us to be too far ahead of the other section. So this is just about where I am on the other section. So we are going to conclude today's lecture right here.